This is our first video for Chapter 8. This is Chapter 8, Section 1, Areas of Parallelograms and Triangles. What you'll learn in this video is to solve problems involving areas of parallelograms, areas of triangles, and areas of complex figures. And remember, a mathematical expression with one or more variables is an algebraic expression. In this video, you have 5 vocabulary terms you need to define in your notebook. Be sure to label that area of your notebook as vocabulary or terms, write down all of the terms, and when you see their definition in the video, pause the video and write them in your notebook. The terms you have for this video are area, base of a parallelogram, height of a parallelogram, base of a triangle, and height of a triangle. The area of a figure is the number of square units it contains. To find the area of a parallelogram, you multiply the base by the height. Any side can be considered the base of a parallelogram. The height of a parallelogram is the perpendicular distance between the opposite bases. So you could take this same shape and turn it in a different direction, and you just need to decide which one is your base and then figure out the height from there. So your formula for an area of a parallelogram is A equals B times H, because A obviously stands for area, B is for base, and H is for height. Please copy this box into your notebook showing the formula and then the 2 ways you can show height versus base in a parallelogram. Now let's look at an example of finding the area of a parallelogram. So with this given parallelogram, well, first we know it's a parallelogram, so we have to use our formula for the area of a parallelogram. So the formula we need is A equals B times H. And remember, our base is the one going along the bottom, and our height is the one that goes from top to bottom. So if we're going to take our formula, we're going to replace the B with our base measurement and the H with our height measurement. So a formula becomes A equals 5 times 3 if we substitute both the B and the H with the values we're given. So that's a very simple multiplication, so we know that our area is 15. So the area of the parallelogram is 15 meters squared. Now remember, when you're doing area, whatever measurement you're multiplying is going to become squared. So if it's inches times inches, it becomes inches squared. Meters times meters, meters squared, and so on. Whatever your unit of measure is will become squared in your final answer. Pause the video and try this quick check in your notebook. Remember to label it as either exercises or quick checks and number it, and then show all of your work. Remember, your formula for the area of a parallelogram is A equals B times H. Now let's talk about triangles. Just like with a parallelogram, any side of a triangle can be the base of a triangle. The height of the triangle is just the length of a perpendicular segment from a vertex to the base of the opposite of the vertex. So, I know that sounds complicated. So, the base is just whatever side they've decided is the bottom, and the height is a line that tees up from that base straight up to one of the points or the vertexes, or the vertices rather, of the triangle. So, if I have a triangle that looks like this, and I've decided down here is my base, my height is a line going straight up, well, should be straight up, let's try that again. A line that just goes straight from the point down to the base, and it should always be a right angle. So that's why you see these little squares written in the bottom, is to show it's a right angle. So it doesn't matter what shape the triangle is, your height is always going to be perpendicular or straight down to whatever your base is. So the diagram shown shows that the area of a triangle is half the area of a parallelogram with the same base length and height, or A equals half base times height. So your formula for a triangle is A equals half the base times the height. Now let's look at finding the area of a triangle. Say you're part of a conservation group, and your conservation group plans to buy a triangular plot of land shown. What is the area of the plot going to be? So first we know our formula for finding the area of a triangle is half the base times the height. So we have A equals half B times H. So we're going to replace the B with 30 because our base is marked as 30 kilometers, and replace the H with 10 because our height is marked as 10 kilometers. So that would look like half times 30 times 10. So half of 30 is 15, and 15 times 10 is 150. So the area of our triangular plot is 150 square kilometers. Just like with parallelograms or any area, your answer is always going to be whatever the measurement is squared. Pause the video and do this quick check in your notebook. Be sure to number it and show all your work. Remember, your formula for the area of a triangle is half the base times the height. Now let's talk about finding the area of a complex figure. A complex figure, by definition of the word complex, means a shape that's a little more complicated than the previous ones we've talked about. It's not a basic rectangle, it's not a basic triangle, it's not a basic parallelogram. It's got all these bumps and angles and weirdness going on. So sometimes you can split a complex figure into smaller polygons. So shapes that are easier to figure out, or shapes we're more comfortable with. So let's look at the one here at the top. So if I have this shape, I have a couple different choices. Basically, I know I'm going to want to split it into 3 rectangles of some sort. Now, there are several different choices. I could split it here and here to give me 3 rectangles with these shapes. Or I could cut it here and here and give myself a small rectangle, a long rectangle, and a square. Or I could split it here and there to give me 3 rectangles. It does not matter. The area of a shape is the area of a shape. You just have to make sure that when you make your cuts, if you will, that you're able to figure out the measurements that are missing. For instance, for this distance, we know that that's 2 because this is marked as 2 and it's the same height. We know that this is going to be 5 centimeters because this one is 5 centimeters. So you need to think about what are the measurements of those shapes going to be after you split it apart. For this one, it's already split for you. So obviously, there's only one place you can split this complex figure, because if I tried to split it here, it would just give me extra weird shapes. And I guess, yes, you could split it here and give yourself 3 rectangles instead of 2, but that's just giving yourself an extra calculation you have to do. Generally, you want to try to make as few cuts as possible, because if you make more than you absolutely have to, you're just making more work for yourself. So while yes, I guess I could cut it here and here, there's really no reason to. I can just cut it in half and deal with the 2 smaller pieces. Same thing down here. Again, there's going to be several places you can cut it. You could cut it here and here. You could cut it there and here and here. Doesn't matter, again. As long as you can figure out what the measurements of are of the sides that you've cut it into, you're fine. Same thing here, just cut it wherever makes sense to you. Yes, I could have cut this into, I don't even know, that would have been 5 or 6 shapes. But again, you want to make as few cuts as possible just to save yourself work, because the area of the shape is going to be the area of the shape no matter how many pieces you cut it into, because cutting it into additional pieces doesn't make the area smaller, it just makes it into more manageable pieces. Now let's look at an example of actually finding the area of a complex figure. So we want to find the area of this figure. So we're going to split the polygon into 2 rectangles and 1 square as shown by the dashed lines. Could we have split it differently? Yes. But for the sake of this example, we're going to stick with these shapes. So first, we need to find the area of the smaller rectangle, which is going to be 3 times 2, which gives us 6 inches squared. And the area of the larger rectangle is going to be 6 inches minus 2, which gives us 4. And then we've got 3 inches plus 2 inches, which gives us a side of 5. So 4 times 5 is 20 inches squared. Then the area of the square is 2 by 2, so 2 times 2 is 4, so 4 inches squared. So to find the area of the entire figure, we just need to add all of those amounts together. So 6 plus 20 plus 4 gets us 30, so 30 inches squared is the area of the complex figure. Pause the video and do this quick check in your notebook. Be sure to number it as number 3 and show all of your work. Now it's time to check your understanding. Pause the video, label this section as check your understanding in your notebook, number your answers, and show any work, or be sure to fully explain your answers. Enjoy the rest of your evening, and I'll see you tomorrow.